We're going to start our factoring lesson today with some just some things to think about. If I tell you 2x plus 16 and I ask you to factor this expression, the very first thing that I always want you to think about in every single problem that we factor is, can I make it easier on myself from the beginning? Is there something that each of these terms is divisible? Is there something that each of these terms have in common? Both of these terms are divisible by 2, aren't they? If I divide a 2 out of each term, what do I have left? X plus 8. Done. Three xy plus 5y. Is there anything that both of these terms are divisible by or have in common? A y. Okay? If I factor out a y, if I divide a y from each term, what do I have left? 3x plus 5. Done. 10x cubed plus 5x squared y plus 10x. Is there anything that every term is divisible by or has in common? Okay, first of all, they all have an x, don't they? And all the coefficients are divisible by 5. So wait, we can take a 5 and an x out at the same time? Yes. Okay. If I divide each term by 5x, what do I have left? 2x squared. Why 2x squared? 2 is pretty obvious, right? 10 divided by 5 is 2. Why x squared? Very good. X cubed divided by x to the first power. We subtract our exponents. We have x squared. Good. What about the second term? xy. How about if I write xy like I said? 5 divided by 5 is 1. X squared divided by x is x. And then there's just a y left, right? What about the last term? Plus 2. Do you know the math word of what we just did, or math words, I guess I should say? That's closer. It's the greatest common factor. Because while we were absolutely looking for a common factor, we were truly looking for the greatest common factor. And that terminology is really confusing to some people sometimes. Because if I say, what is the greatest common factor, doesn't it kind of imply that it's going to be a big number? Okay? Some people think that though, and they get confused. The greatest common factor between 2 and 16 was 2. It's the greatest number that will divide evenly into both of these numbers. And in fact, that has to be at least as small as the smallest number, doesn't it? So just be careful with that. Okay? So before we do anything on any of these problems that we're doing today, we want to look for a greatest common factor. Once we have looked for and taken out, if there's one, a greatest common factor, the next step in factoring really depends on how many terms you have. Where you go, what you think about, where you head really depends on how many terms you have. What are the possibilities, do you think, for how many terms? We talked about classifications yesterday, didn't we? What kind of classifications can we have? We could have a monomial, but are we going to factor a monomial? No. We might factor a monomial out, like we did right here, right? But we're not going to just be given something like 10x to the third and asked to factor it, are we? There's nothing we can do. Okay, so what else might we have? A binomial? maybe a trinomial, and maybe just other polynomials, right? For the record, in Algebra 2, we primarily focus on binomials, trinomials, and polynomials with 4 terms. Every once in a while we'll have one with 5 where all we're doing is taking out a greatest common factor, but primarily it's binomials, trinomials, and polynomials with 4 terms. Okay? So let's start off easy. Anybody have a problem with that? If you do, just get out. Anthony. Let's start here with a binomial. Does anybody notice anything in particular, anything particularly interesting about either of these two numbers? $25 is a squared. Is that important? Very. Okay? Wait a second. Remember I said either of these two numbers? So you notice that 25 is a square. Isn't that one a square also? Oh my goodness. What's happening these two numbers? What kind of operation are we having here? Not appendix, but subtraction, right? That was just a little joke. It's fine. That's okay. Because like you can have an appendix operation. If your appendix bursts before you die, they want to take it out. Okay, sorry about that. I didn't mean to confuse you. Okay. Let's see if my distraction worked. What do you notice about these things? They're squares. This one is a square. This one is a square. And what's happening to them? Noticing those things are very, very important. Because once you notice that they're both squares and they're being subtracted, you have discovered difference of squares. And once you decide and figure out that something is the difference of squares, there's a pattern to follow for that. Okay? I could take you down deep into the mathematic exploration of these numbers and talk about like deep math stuff about this, but I really rather just show you the pattern. Is that okay? Anybody have a problem with that? You ready for the pattern? X plus 5, x minus 5. Done. Okay, where did that come from? Where did the x's come from? Yeah, the square root of the x squared, right? Where did the 5's come from? Square root of 25, right? Why are the signs opposite? The 25 is negative, right? First of all, so I know I have to have opposite signs here. It does. It cancels out a middle term that we might have, right? Can I show you what I mean by that? What if I went backwards? What if I said x plus 5, x minus 5, and like distributed? Isn't that x squared? Oh, that's minus. Minus 5x plus 5x minus 25. What happens to a negative 5x and a positive 5x? It's 0. What's left? Okay? We can factor, we can multiply to check our answer if we wish. Okay? It's not required, but kind of helps you out. It gives you a way to check your answer. But see, from here to here, then I'm done. Okay? Any questions about that? Should we try another one? Okay. X squared minus 36. What do you notice? They're both squares, and? So what do I get? So I did something to try to trick you. Did it work? On the first answer, I wrote x plus 5 and x minus 5. On the second answer, I wrote x minus 6 and x plus 6. Is it the same thing? Absolutely. Okay? So why did I write it opposite? So we could have this conversation, right? Because I needed to make sure you understand it doesn't matter. Because really, aren't they exactly the same except for the sign? They're the same factor except for the sign. We just have to make sure they are opposite signs. That's important. Okay? So can I give you a harder one? You are so excited for the harder one, aren't you? What do you notice? Oh, what's the square root of 18? I don't know either. What's the square root of 2? Guys, the square root of 2 is not 4. So we should start with our greatest common factor. Neither one of these other two that we've already done did we do that because they didn't have a greatest common factor, did they? So if I start this problem by looking for the greatest common factor, then I end up with x squared minus 9, like you said. What do you notice about that? That's the difference of squares, isn't it? So what should I end up with? X plus 3, x minus 3. Excellent. Any questions? I have to leave the 2 in front of it because it's still part of the original problem. I just have to carry it along with me like one of those friends you take with you to the movies, even though you don't really like them, they tag along and you just let them. No names, no names. We just have to kind of keep it with us because we can't just like ignore it. Okay? What do you notice? What do you notice? Is it the difference of squares? What times what equals 49? 7. What times what equals 4x squared? 2x, right? Is it the difference of squares? Yes, then what are my two binomials? 2x minus 7, 2x plus 7. Done. The difference here is, guys, there's no greatest common factor to start with. They're already both squared numbers, aren't they? Okay? What do you notice? They're both squares. Is it the difference of squares? Yeah, is this the difference of squares? What is it? Sum of squares? Okay. Yep, this is sum of squares. Because see, it's a plus sign right here. So that's the sum of squares. Everybody look up at the screen. Please watch really closely while I factor the sum of squares for you. Done. I said done.
Wait, what did you do?
I didn't do anything. What is a number called if it can't be factored? Like 3 or 7 or 11. They're prime. The sum of squares is prime. It cannot be factored any farther than it already is. Okay? Any questions about that? Difference of squares absolutely can be factored. Sum of squares is prime and it cannot be factored. Okay? There's nothing that I can multiply that will just give me this. You notice when we first started talking, we talked about how these two terms have to be opposite signs so you can get a negative 25. If these two are both positive to give me a positive 81, it'll also give me a middle term. If these two are negative to give me a positive, I'll also still get a middle term. Okay? So there's nothing that I can multiply together to give me this because it's prime. All right? What do you notice? That's a cube. Are they both cubes? Do you know your cubes? Look over here at the sideboard. I wrote a chart for you right over here. 2 times 2 times 2 is 8. So 8 is a cube, right? So what do you think this is called? Difference of cubes. We will. We'll do the sum one in a minute. The difference of cubes has a different pattern than the difference of squares. Okay? The pattern for difference of squares was what? 2 binomials, right? Difference of cubes, the pattern is binomial, trinomial. Okay? The difference of cubes, the pattern has a binomial and a trinomial. So first I want to teach you about the binomial because it's the easiest one. Okay? What times what equals x cubed? X. That goes at the beginning of the binomial. It's also called the cube root of this first term. Okay? What times what equals 8? 2. It goes in the second part of the binomial. I'll tell you in just a second. I got to get a little mathy here. We're going to call that one A and that one B. Okay? To find our trinomial, for the first term in the trinomial, we're going to say A squared. So in this particular problem, what goes right there? X squared. The second term in our trinomial is AB. So what goes here? 2x. And the last term in our trinomial? B squared. So in this particular problem it is, which is 4. So what am I missing? Signs. Okay? The signs also go in a pattern that don't always go with the numbers that are there, but the signs always have a pattern. Okay? In the binomial, whatever sign is in the problem, that's the sign that goes in the binomial. It's x cubed minus 8, so the binomial is x minus 2. Got it? The next sign is opposite of that. And the last sign is always plus. Okay? Because see, if we put the signs in as we go, somebody please tell me what this middle term should be. What's A times B? Isn't that negative 2x? And that confuses people sometimes. So that's why I put the signs in at the end. Fair enough? Okay, let's do another problem then. I'm going to jump in with both feet here. (125x cubed minus 64). What do you notice? Are they both cubes? Are you sure? Good. So that means I'm going to have a binomial and a trinomial. What goes in the first space of the binomial? 5x. Very good. Everybody see where that came from? Okay, what goes in the second term of the binomial? 4. Good. Okay, what goes in the first term of the trinomial? Oh, be careful. I want to square this whole thing, not just the x. So 25x squared. Very good. What about the second term of the trinomial? 20x. And the last term? 16. That does say 125, yes. But if I'm squaring this term right here, 5 times 5 is 25. Now let's do my signs. What's the pattern? Whatever's in the problem goes in the binomial. The next one is opposite of that. The last one, always plus. Questions? I don't know what you mean. I'm sorry. Whatever's in the problem, that goes in the binomial. That's a good question. Can I look it up in a minute? Okay. Thank you. All right, what do you notice? They're both cubed, right? Same pattern? Is the Okay, so this time we have two different variables, don't we? Is this the difference of cubes? It's clearly cubes, right? But it's the sum of cubes, isn't it? So the good news is that you already know how to do this. Okay? The bad news for you guys, I think would see it as bad news, is that the sum of cubes is factorable. You can't just put prime and go on. Okay? But the good news is that you already know how to do it. Because of how I taught you the pattern for these, it's exactly the same pattern. First of all, somebody noticed this isn't the sum of cubes because they're both divisible by 2. And we've got to take care of that first, right? We get 8m cubed plus p cubed. Is that the difference? The sum of cubes? It is, isn't it? Okay? So I get a binomial and a trinomial. What is the cube root of 8m cubed? 2m. What is the cube root of p cubed? P. What's the first term in the trinomial? 4m squared. Very good. What's the second term of the trinomial? 2mp. Excellent. And the third term? Good. P squared. What is the pattern of the signs? What's the sign in the problem? Plus. What's the next sign? It's opposite of that. And the last sign? Always plus. Got it? Difficult? No. Yes, ma'am. 4m squared. I took this 2m and I squared it. The first term in the binomial, I square it to get the first term in the trinomial. Good question. This one right here? This one? From the first term of the problem, the 8m cubed, what times what times what gives me 8m cubed? And it has to all be the same things. Okay? Does that make sense? In the front? Nope. It's like that friend you just have to drag along with you. No names. So those are all the special rules about binomials. Okay? What seems logical to come next? Trinomials. Guess what? We're not going to do them yet.
Yes.
Okay? Because first, I know this sounds a little crazy, but you've known me for a while now. I want to do polynomials with 4 terms first because they're easier. Okay? Polynomials with 4 terms are easier. Can I prove that statement to you? Because that doesn't look easier to me to start with, does it? Visually, it doesn't look easier, does it? When we have polynomials with 4 terms, I'm going to try to factor by grouping. That's what I'm going to try to do, is factor by grouping. Which implies what? I'm going to group some of them. Okay? I'm going to group the first 2. Which means I'm going to ignore the second 2 for just a moment. Just looking at the first 2 terms, is there a greatest common factor? Is there something they have in common? 2x. If I factor out a 2x, what's left? And I'm only factoring it out from the first 2 terms. I haven't looked at the last 2 yet, have I? 6y plus, what's 2x divided by 2x? Okay, what's 5 divided by 5? What's 12 divided by 12? 106 divided by 106. Anything divided by itself is 1. So what is 2x divided by 2x? 1. Is there anything else I can do to that? You know what this crazy kid earlier said to me? Well, 6y plus 1 is 7y. What did I say? Well, I didn't say get out of my class out loud, but I wanted to. Is 6y plus 1 7y? No, you can't combine them. They're not like terms. Okay? One of them has a variable of y, one of them doesn't. Is there anything else I can do to this? No. Then ignore what I just did for just a moment and just look at the last 2 terms. Or is there anything common in the last 2 terms? 5. What's left when I divide a 5 out of each term? 6y plus 1. Is there anything else I can do to that? Now, look at them. You notice anything? What's the same? The parentheses is the same. If we get to this point and the parentheses are the same, we're golden. We got it. If the parentheses is not the same, we stop. Okay? But if the parentheses is the same, I'm about to write the answer for you. Where in the world did that come from? What did I factor out? The 2x and the 5? What did each half have in common? The 6y plus 1. That is the answer. Okay? Most common question I get right now is what happened to the other 6y plus 1? That's not an illogical question, but I want you to think about it for a second. If I was starting here and going backwards, I would distribute, wouldn't I? And I'd say 2x times everything in this parentheses, and then 5 times everything in this parentheses. Wouldn't it look like that if I wrote it out? So is there really an extra 6y plus 1? Or is it just the other term multiplying by it? This, guys, is the answer. We're done. Okay? If this was like 6y plus 2 and then was 6y plus 1, that's it. That's the answer. We can't go any further if those parentheses are different. Okay? So let's try this one. Just look at the first two terms. What do they have in common? X. What's left if I divide each term by x? X plus 8, right? Okay, now I need to think about this for just a second. I know I have to have what? Another parentheses that says x plus 8, right? Is that possible? Given x plus 8 right here. Yes, but I also know in order to write this first parentheses with the two things I factored out, I have to factor something out. What do these two things have in common? Even if it's only one, I have to factor something out. When I divide each of these terms by 1, I get x plus 8. Are my parentheses the same? Then tell me the answer. X plus 1 times x plus 8. That is the answer. Okay? Any questions? Okay, I want to do one more thing before it's time to go. And that's directly related to the flip video from last night. Okay? I ask you to think about some things like what two numbers multiply to be 10 and add to be 7. What two numbers multiply to be 10 and add to be 7? 5 and 2. What two numbers multiply to be 24 and add to be 10? Wait 5 seconds. Now tell me. 6 and 4. What two numbers multiply to be negative 49 and add to be 0? Negative 7 and 7. She forgot. Multiply to be negative 6 and add to be negative 1. Wait 5 seconds. What is it? Negative 3 and 2. What two numbers multiply to be negative 6 and add to be negative 5? Wait 5 seconds. What is it? Negative 6 and 1. Right? That's what I asked you to do on the flip video last night, didn't I? Can I show you how it matters now? Okay? Because these now are going to become trinomials. I talked to you about binomials. I talked to you about polynomials with 4 terms. This thinking goes along with this trinomial. It's going to look like x squared plus 7x plus 10. And we're going to think, what two numbers multiply to be 10 and add to be 7? And when I write my answer, I'm going to write x plus 5, x plus 2, and be done. This problem will look like x squared plus 10x plus 24. And I'm going to write my answer by thinking, what two numbers multiply to be 24 and add to be 10? X plus 6 and x plus 4. And this one was kind of a trick one, because it's not really a trinomial at all, is it? Because it would be x squared plus 0x plus or minus 49, which is really just this, isn't it? But do you see why now the answer is x plus 7 and x minus 7? Does that maybe make that a little bit more sense? Make a little bit more sense? So tell me then, what would the problem be for this set? X squared. Minus x. Minus 6. And what are my factors? X minus 3, x plus 2. Done. What does the last one look like? What's the last problem look like? X squared minus 5x? Minus 6. Perfect. What are the factors? Very good. So this crazy kid earlier, on this one right up here, you know what he said? He said, I wrote x plus 4 and x plus 6. What did I say? That's fine. On this one right here, he said, I wrote x minus 2 and x plus 3.
Kingston, do you have Brandon Coleman?
No, I had him last grade. He's in Miss Clower's class this period now.
Yes, ma'am, thank you.
Thank you. What did I say? It's not okay this time, is it? Because here I had a negative 3 and a positive 2. Here I have a positive 3 and a negative 2. Is that okay? No, the signs are different. That is not okay. What would be okay? X plus 2 and x minus 3 would be okay, wouldn't it? Okay, it's the same sign, it's just a different order. Does that make sense? Okay? That's as far as we're going today with factoring. Okay? Because if you'll notice on the trinomials, I didn't give you any trinomials with a number in front of the x squared, did I? We will worry about that tomorrow. Peace.